In fact, altitude is one of 5 major factors that affect climate. If you walked up a mountain pathway, for example, you would find that the temperature would drop 3.5 degrees Fahrenheit for every 1,000 feet you climbed, or 6.5 degrees Celsius for every 1,000 meters. Another of the 5 factors that affect climate is latitude. Because the sun's radiant energy shines directly on areas nearest the equator, that is where the warmest areas of the Earth are found. Farther to the north and farther south, the angle of sunlight becomes smaller, so there's less heat from the sun at those locations. At the North Pole and South Pole, the angle of sunlight is so small that very little heat finds its way to the Earth's surface in those places. Latitude takes on added importance as the Earth makes its annual journey around the sun. That's because the Earth tilts roughly 23.5 degrees on its axis. So when it's at this position in July, it's summer in the northern hemisphere, because the sun's light and heat is aimed more directly there. At the same time, it's winter in the southern hemisphere. Half a year later, in January, when the Earth's position is here, it's just the opposite. Now the sun's light and heat are aimed more directly at the southern hemisphere, so it's summer there, and winter in the northern hemisphere. Now, on to the third of the 5 factors that affect climate, the Earth's topography, that is, its surface features. Mountain ranges are an example of a topographical feature that can play a major role in a climate's precipitation levels. As humid air moves in from an ocean and then sweeps upward across the mountain slopes, the air cools, and the moisture swept off the water begins to form a cloud. As the tiny water droplets in the cloud come together, they become heavier and then fall to the ground. As the air skims down the other side of the mountain, it heats up and the cloud vanishes. The side of mountains facing away from oceans are often dry. In addition, a so-called rain shadow may stretch more than 100 miles downwind from a mountain range. Rain shadow areas are known for their dry lands and dry air. Oceans and large lakes, the fourth of the 5 factors that affect climate, often moderate what might otherwise be more extreme weather conditions. An example occurs in San Francisco, California, on the shores of the Pacific Ocean. San Francisco and St. Louis, Missouri, a city some 2,000 miles or 3,300 kilometers to the east, lie at about the same latitude, and so get about the same amount of solar energy each year. Yet San Francisco's climate is much less extreme than that of St. Louis. Summers are mild and winters are cool there, while in St. Louis, summers can be blistering hot and winters very cold. The difference is the moderating winds that blow off the surface of the Pacific Ocean. They act as a kind of giant air conditioning system. Or take the case of the British Isles, which for the most part have mild summers and cool and rainy winters. The northern tip of the Isles is located on a latitude that runs north of Moscow, Russia, a city that has cold, snowy winters and very short, cool summers. The contrast is caused by the warm ocean waters that flow by the Isles, waters that originate off Africa's west coast near the equator. Now, on to the Earth's winds, the last of the 5 factors we'll discuss that affect climate. There are 6 belts of winds that encircle the Earth. They push along warm and cold air masses, moisture, storms, and pollution. What are called trade winds meet near the equator, causing air to rise. As it does, rain clouds form. This band of cloudy, rainy weather near the equator is known as the doldrums.